I want to welcome you for this online lesson. I am Yando Amos, the learning facilitator for physics. So we are going to have our presentation here on physics, and these are on Yaaka Digital Learning Network online free lessons or free learning classes. These lessons kicked off, as you can see from there, on 21st June. For those who encourage them to register, my contact is there. For products, these are some of the products that we offer as Yaaka. Yaaka offers a range of products. These products are with their price tags there. You can see we have online classes that run for Ghana shillings 500,000. It includes several teacher-student interaction where we hold like class engagements of such a nature, and we also enable you to have access to courses or the subjects on the website at yaaka.cc, marking and grading of assignments and quizzes for a full year. So which means all these packages only given out at Ghana shillings 500,000. You can enroll for that. We also have several other downloads that you can make on our site for a single subject. For a single subject, if you want one subject, that one goes for 10,000, and then all the subjects in the climb and then the class of primary sections go for 30,000, which means if you want all the subjects in the primary section, they go for 30,000. Meanwhile, all the subjects per class in secondary, you can get their notes at 50,000. You can download all those downloads. You can get them at 50,000. We are doing this online classes in line with the collaboration from the Educare. Educare is one of the rich education sites where you can you can access a number of resources, learning resources from P1 up to Senior 6. We have quality learning notes, including even videos, and then the price tag has actually been specified there. But before you can have that, there's a package where you can go for 2 days on free access. Then after that, you can be able to enroll on per month or per quarter, on half a year, on annual basis. Quarterly, there is, I think, after a period of 4 months, a period of 3 months, you can enroll for 3 months at 50,000. Monthly is 20,000. We have 70,000, which is half a year, or the full year you can enroll at 100,000. I want us to move on to our area of interest. As of now, we're going to introduce physics practicals. Now, one of the papers that you will be sitting for at the end of your S6 would be physics practical. It constitutes a paper of its own. It is paper 3, where we have 3 areas examined mainly. And the first one is always mechanics, which is compulsory. So for someone who's going to be doing physics, or you who's doing physics know that you will sit for physics paper 3, which is the practical paper, and the question 1 is compulsory. It is on the area of mechanics. You know what is covered in mechanics, the area covered in mechanics. And then secondly, we have 2 other questions that will come from the areas of light or heat. Then the other one will be from electricity. So from those, you'll be picking now 1, which means you answer at the end 2 questions. You can choose to pick that one from light, or you pick the other one from electricity. Then at the end, you will have met the conditions of the examination there. But we have several areas. As we introduce you to this physics practical, there are several areas that are examined. One of these areas which is examined is the concept of physical quantities and their units. No, when you are always introduced to physics in senior 1, even the first thing they always look into is this. Physics is all about talking about the physical quantities, and then certainly how to measure them. Now, how do we measure them? In order to measure these physical quantities, we now use what we call the measuring instruments. We now use what we call the measuring instruments. So you needed to know how to measure these physical quantities using the measuring instruments. So it is a very important area that you need to understand. And at the end of it all, we should have looked at these areas. Our major concept here, I mean, the major issue we are into here is yet trying to understand the basics of the physics practical. The hands-on shall be done later on. Maybe you follow us from the videos that we shall be able to have from our site. And then as you saw, do on your hands-on. We have concept of rounding off and all significant figures, meaning that this can be both or. In most cases, one is given. So there are cases where you'll be rounding off and having significant figures, or you'll be rounding off, or a significant concept of significant figures is tested. But this is a very important area you need to understand. This helps in data manipulation, how to interpret data, how to analyze data. It helps us so much from there. This area of concept, this area of rounding off and significant figures. Next that we have is the area of trigonometric ratios and logarithms. Trigonometric ratios and logarithms, how do we move on to record, to work out areas concerning this trigonometric ratios and the logarithms? Now, when we talk about trigonometric ratios here, we're meaning the sine, the cosine, and the tangent. So how it's a question of how do we record when it comes to measuring areas other that. Then we shall look at roots and the numbers, roots of numbers and even numbers themselves. So how recordings of those can be done. And importantly, we don't need to leave out recording of data in tabular form, which means data recording on the table. How do we record the data on table? What do we do in order to record that on table? What are the things we do? We shall be able to look at each of these ones in the coming lessons, I think, one after the other. And then we have the last area is the graph work. After the data is recorded on the table, you will move to graph work, and then there are a lot of areas which are also examined under graph. We shall look at those ones like the title, scales, intercepts, and so on there. And then its interpretation. The interpretation now moves to data manipulation. But these concepts that are examined require that you have certain skills. They require that you have certain skills. I know all of you who are doing physics at this level, you already had done a lot in all level. You had done a lot in all level. Many of you might have passed physics well in all level because of theory. Many of you must have passed physics well in all level because of the practicals. Or many of you might have done extremely well because of balancing your efforts in both papers. Now here in level, it is very important that you need to do much better in order to do better here. You need to comprehend and follow instructions. Is that clear? Are we together? You need to comprehend and follow instructions. Derek, are you getting us? This instruction is all about what is given there. So you have a set of procedure. That set of procedure follows the instruction, follows now is what we refer to as the instructions actually. Right from there, how do you go about with the experiment? They'll first say, you maybe you climb, you tie this. Those instructions, then just follow them the way they are. When you follow those instructions the way they are, this will help you in extremely performing well in the practicals. So you need to comprehend and follow instructions. When they say do this, do it as they have instructed you to do. Next is the correct use of the measuring instruments. I want to say something about this together with the correct use of the precision of the instruments. Samson, could you mute your microphone? Samson. Could Samson mute the microphone? That noise. Oh, thank you. I'm trying to talk about the correct use of the measuring instruments. I know later on we're going to look at some of the measuring instruments, but we are basically going to discuss. I think we should be preparing our minds to discuss on the measuring instruments. We shall be going a little bit with them so fast because these are some of these instruments that you also have used previously. So we may not be delaying so much there. I'm just saying that the measuring instrument, the first thing is, do you know how to measure using that instrument? That is the first skill needed. Do you know how to measure using the instrument? Who can just give me an example of one instrument, measuring instrument that we commonly use in physics? By putting up a hand, you can give me one example of a measuring instrument in physics, practical, that we commonly use. Marvin.
The vernier calipers.
Very good. We have vernier calipers. Now, when you are using the vernier calipers, the first thing here, the skill we're concerned of is, do you know how to use vernier calipers? Do you all know how to use vernier calipers? Do people know how to all use vernier calipers?
No.
In measure. Now you can see. So the first thing we shall have to know is how to measure using vernier calipers. That is the first thing. Then the second thing, if we know now how to measure using it, what is the precision? What is the accuracy of the instrument? The accuracy is now the smallest unit to which that, in fact, the instrument can be able to take a measurement. The smallest, what is the smallest instrument? I mean, the smallest unit that the instrument is able to make a measurement to. For instance, if you take the vernier calipers, what is the smallest measurement that it can make? How many decimal places? That brings us what we call the precision or the accuracy of the instrument. Is that okay? Then the next aspect, which is very important, is ability to get reciprocals, the powers, you know. Sometimes we even talk of quotients, which we have not actually been able to bring here. We talk about ability to get the reciprocals. How do you get the reciprocals? Interpretation, data manipulation there. How do we get the reciprocals? How do you get powers? How do we obtain quotients? This is a very important skill which is required. Another very important aspect is writing units correctly where necessary. I'm actually saying that where necessary is because you find that there are some quantities as we're going to make measurements, as we're going to take measurements, the quantities do not have units. Are you aware that there are some physical quantities that do not have units? Derek, are you with us? Are you aware that there are some physical quantities that do not have units?
Yes.
Marvin, are you also aware that there are some physical quantities that do not have units?
I was not aware.
So you're going to realize that there are some units, I mean physical quantities that do not have units. Then we also have this writing of these symbols for the physical quantities. I want maybe just on the units there. Let me try to come back and throw more light. As one of you saying is not aware, many of those quantities which are obtained as a result of, which are obtained from ratio, which means you have to divide two quantities which have the same unit. You find the units will cancel out, okay? The units will cancel out. Then at the end, you end up having now a unit, a quantity without what? Unit. So correct symbols. This is very, very important. If I will ask what is the symbol for kilogram, if I'm to tell someone to give me the symbol for kilogram, I think we shall get someone going astray. What is the correct symbol for maybe degree? Someone will not be writing it the correct way. So how to write these symbols the correct way is what we're also going to have. Is that okay? These are the skills that you need to have. And at the end of our lessons, or when you continue to be with us here at Yaaka, you'll be able to get this. Then we have the use of scientific calculators. There are some of you who do not know sometimes in which mode you should be put in the calculator to have a certain to have certain calculations. For example, maybe if I want to work out a normal calculation, to which mode should I put it? Many of you will be putting your calculators to radian, and then yes, someone has just given us a correct answer that you'll be putting your calculator on a radian, then the answers will all be very wrong. Is that okay? For correct calculations, your calculator has to be put on mode of degree. Many times on the calculator, you see it is on our scientific calculator, you see D being displayed on the calculator. On the on the other electron, you get that D. On the scientific, the small ones that we commonly use in O level, many people always continue to use it in A level, but it is advisable you use the other type. You find it puts there DEG. So that's what you expected to use. And above all, there are more other skills that are needed, but don't leave out on the skill of following the rules of data manipulation. Rules of data manipulation. When you are adding, when you are subtracting, when you are dividing, or when you are dividing, or when you are multiplying, these ones here are very important enumerations that we carry out in physics practicals. But when you're doing those ones, what you need to do is there are certain rules that we follow, and you needed to follow those rules. And then in our consequent relation, and in that we follow, we'll be able to look at some of these skills, and you'll be eventually able to get them. And then I just did say that in the measurement in the physics practicals, you mainly deal with the physical quantities, and then we are actually we categorize these physical quantities into two. We have fundamental quantities and we have the derived quantities. We are going to define fundamental quantities and then also give examples. I also ask you to define for me derived quantity, and then we list some of the examples. What is a fundamental quantity? So you put an upper hand. By raising your hand, who's trying to define for me what fundamental quantity is? Who's defining? Derek?
Fundamental quantity is a physical quantity which cannot be expressed in terms of other quantities.
Physical quantity which cannot be expressed in terms of other quantities.
Quantities.
That is good. That is according to him. Who else has a different view? Who else? Is there someone with different view? These fundamental quantities, as he has just well stated it, are physical quantities which cannot be expressed in terms of other quantities. What is the other name for fundamental quantities? What is the other name for fundamental quantities? It is commonly a term which we prefer using in O level. We call them basic quantities. They are basic quantities. So we can, instead of sometimes calling fundamental quantities, we say basic quantities. So fundamental quantities or basic quantities are the quantities which cannot be expressed in terms of other quantities. Let us now move on to mention some of the examples. Trevor, give us one example of a fundamental quantity.
We have length, mass, time.
Trevor. Trevor has given us length, mass, time. Patricia. I mean, Trevor has given us there. There's one participant who has just also joined. Viva is Viva Jenna. In the names of Viva Jenna. Can you give us one example of a fundamental quantity apart from mass, length, and time? Derek, could you mention one other apart from those ones mentioned? No, those are the common ones that we do have, but we have other fundamental quantities. Some of the examples which include electric current, even temperature. These quantities you need to know. They are simples. You need to know the SI units of these quantities, and then you need to know other. After knowing the simples, the SI units, then the simple of the SI units as well. Those ones you need to know them. This is what is just important with this area. What about derived quantities? What are derived quantities? Could now someone define that other than Derek? Because could someone, Trevor is saying, wants to try?
Derived quantities are quantities that are calculated from 2 or more measurements.
Good. Quantities which are calculated from 2 or more measurements. In other words, they are now quantities which were obtained from what? The fundamental quantities. Let's briefly mention some of the examples. What are some of the examples of these derived quantities? There are very many of these examples. Unlike fundamental, which are just few, there are so many of these quantities which are in that category of derived quantities. You can just give Marvin, Derek, Trevor in that order. Mention
Force.
one. Force. Next.
There's also density and volume.
Density and volume. If we can move to where we're saying there, you can now see it is just summary of what we have discussed. I want who's going to read for us the first bullet? Who's going to read for us the first bullet there? Simon, you can move on to read. Simon.
Fundamental quantities cannot be derived from any other. For example, length, mass, time, temperature, electric current.
Next, we move to Derek. I'd put up his hand. Derek, read for us the bullet on derived quantities. As Martin will wind up with the last one on also the derived quantities still. Derek, can you read through the second bullet? Seems not to be getting us. We're saying derived quantities are now obtained from the fundamental quantities. We have some examples here. We have area, volume, density, energy, power, force, Young's modulus, acceleration, velocity, fractive index, resistance, resistivity, and so many others. See, there are so many others that we have left out. Now, you have this assignment that you need to now do on your personal basis, and then you need to know it. You need to understand each of these physical quantities, their symbols, the SI units for each of them, and the symbols for each of their SI units. That is the task that I want you to do on your own, and then you need to master it. It is going to help you in the coming lessons. Then we have derived quantities cannot be directly measured in experiments, but they obtained from the given expressions. Hence, they assume the derived units from that expression. Maybe an example we can have is, see how we can be able to determine acceleration due to gravity or in experiments in mechanics. You see, it all starts from measurements of lengths and using certain masses, but it will now end up in the giving us the value of what? The acceleration due to gravity, the value. And even measuring the timing. Sometimes we hang a certain mass and then we allow it to swing, and then using a certain length of a certain thread of a known length, then the timing is done, then eventually we shall arrive at the value of the experiment, the value of the acceleration due to gravity. See, that is how we are able to, acceleration due to gravity or acceleration is just one of the examples of derived quantities. So that's how we can be able to arrive at it. The coordination here we have is that these derived quantities, which are as a result of the derived quantities there, which are as a result of ratio of same quantities, have no units. When we go to the examples, we have a refractive index. In a refractive index, it is a ratio of what? It is a ratio of sine of angles, or in a refractive index, it is a ratio of sine of actual angles. So it is a sine of some angle of incidence to that of angle of refraction. See, they are sine of angles. The sines, because of the quantities, they are same quantities, which means they will not have now units. That quantity will not have units. That is why we are saying somewhere. Now, one of the examples of those quantities which has no units here is a refractive index. We have relative density. We have relative density. Could Juliet just put off that microphone? Mute your microphone, Juliet. We have derived quantities like relative density. Density of one substance as a ratio to the other. So you're expressing one density to the density of another substance. So because they are the same quantities, has no unit. All trigonometric ratios, sine, cosine, and tangent, plus logarithms. Those ones do not have units. To wind up, I want us to briefly mention the common measuring instruments for physics practical. As we move to conclude, could we mention the common measuring instruments for physics practical? Here I'm now not restricting for purposes of saving time. Could
Please, I'm gonna slap you. Wait till I come down. I slap
Marvin, Juliet, could you mute? Marvin, I show your hand up. Mention if your network, Marvin, we cannot get you clear. Your network seems to be breaking, so you can put your answer for us there in the chat. I'll be able to read.
You can use the meter rule.
Meter rule, correct. Meter rule. Another in physics practical, when you are doing physics practical in China or in O level, I know many of you have not done it. A level, were you only using meter rule? There are so many instruments that we are using. Could you mention for us some of those instruments? Marvin has given us meter rule.
You have a voltmeter.
Voltmeter, very good.
Ammeter.
Ammeter.
Spring balance.
We have spring balance. Spring balance, good. Derek is giving us stopwatch. When you are measuring time, you use the stopwatch. Any other? We can see when we move, you can see those we have some of the measuring instruments, some of the common. What can you see that we have there among those ones we have not mentioned?
Thermometer, galvanometer.
Galvanometer, thermometer.
Have protractors.
Protractors. Someone had mentioned for us micrometer, screw gauge previously, so we even have vernier calipers somewhere there. Step measure. See, we have top pan balance. I'm seeing a lot of measuring instruments there. So now the common instruments that we always use. Common instruments, some of them we may not have mentioned all. We have that you have mentioned. We have now the summary here. The meter rule. We use meter rule. We use a stop clock. We have a stopwatch. We have protractor. We have voltmeter. We have ammeter, thermometer, spring balance, vernier caliper, micrometer, screw gauge, tape measure, galvanometer, and then we also do have beam balance, and many others that we have not mentioned here. So those are the common ones that we do have, but we have other instruments that we can also be able to mention apart from these ones. Now I want you, now you're outside work, which means you need to go out after here. We do research on other instruments, but these are the common ones that we shall be looking at. We're going to look at in our next lesson how these instruments are used and what they are used for. We shall be looking at what these instruments are used for and how measurements are done, and also their precision as well. I think all that is what I had prepared for us for this lesson. I thank you for listening and your active participation. God bless you. And need to subscribe to Yaaka and Educare for high quality education materials online.
Hello, miss. Hello. This is hello. Anna.
Hello,
Anna,
David.
hello. How are you? How was the lesson?
This one was good.
Let me say it's available. Should I say that it is also first time for me? It is my first time in Yaaka and participate in it.
Yeah, it's also my first, actually.
Let me hope that we shall succeed in it.
Yeah, we shall succeed. We shall succeed. We have started off well, actually.
But what I want to ask, because when I was checking in the timetable, mostly physics is there on Friday. Then how will we be doing it? Because I've seen that in Friday, it will be